Okay, here we have a mass of 90 grams, an impulse of 12 kilogram meters per second, and it wants us to calculate the speed with which the ball leaves the bat. Now, if this ball is sitting on a tee, the V1 is going to be 0. So we can plug in for impulse 12. For mass, we have to convert to kilograms, so 0.09. And then V2 is what we're trying to solve for, and V1 is 0. And then we solve for V2, and we get 133 meters per second. Now the second part gives us a time. Delta T is 2.5 milliseconds. We change that to seconds and get 0.0025 seconds, and it wants us to solve for force. So we can take that same impulse and set that equal to F delta T, and when we solve for F, we get 4,800 newtons. Okay, in this case we have a mass of 220 grams, which we will convert to 0.22 kilograms. We have an initial velocity of this ball of Play-Doh of 14.2 meters per second. It's going to hit the wall and then it's going to stop, so V2 is going to be 0. The magnitude of the force is what we're looking for, and the time that it takes to stop is 0.17 seconds. So in this case, they don't give us the impulse. We could calculate it, but they don't ask for it, so we are going to use this part equals this part of our equation this time. 0.22 times V2, which is 0, minus V1, which is 14.2, equals the force, which is what we're trying to find, times the time, which is 0.17. Now when we solve for that, we get a negative 18.4 newtons, but the question says what is the magnitude of the force, so we're not going to put the negative in when we put the answer in. So often we are going to talk about collisions having to do with momentum. The conservation of momentum tells us that the momentum before the collision is equal to the momentum after the collision. Momentum is equal to mass times velocity. We could have mass times velocity before equals mass times velocity after. So in this case, we have 12,000 kilograms of mass beforehand, and it's moving at 15 meters per second. And then afterwards, we have the 12,000 kilograms of mass plus 9,000 kilograms that are dropped into the railroad car times the velocity, which is what we're trying to find. So when we solve for this velocity, we get 8.6 meters per second. Okay, in this problem we have a 198 gram softball, which we will convert to 0.198 kilograms. It enters the strike zone, so we're going to imagine this ball going this direction. We're going to call that the positive direction. So V1 is going to be 20 meters per second. The batter hits the ball and it leaves her bat with a speed of 27 meters per second in exactly the opposite direction. So now the ball is going this direction, which we will call the negative direction. So V2 is negative 27 meters per second. We want to know the impulse, and then also it tells us a time segment for the contact with the ball of 1.2 milliseconds, which we'll need to change to 0.0012 seconds, and it asks for the force. So we are going to plug numbers in first to find the impulse. The impulse is equal to 0.198, which is the mass, times the V2, which is negative 27, minus the V1, which is 20. So that's like plus a negative, so this turns out to be negative 47. So when we work this out, we get an impulse of negative 9.31. However, it asks for the magnitude of the impulse, so we would put in 9.31 kilogram meters per second. Now we can take that same impulse and set it equal to F delta T to solve for the force. Force is what we're trying to find. Delta T is 0.0012 seconds, and when we type that in, we get a force of negative 7,800 newtons, but once again it asks for the magnitude, so we're going to put in 7,800 newtons as our answer. Okay. Here we have a pool ball A, which is moving to the right until it hits pool ball B, which is sitting still. And then after this collision, pool ball A stops and pool ball B is now moving to the right. The original velocity of pool ball A is 4.3 meters per second, and because we know that they have the same mass and momentum is conserved, the velocity of B afterwards is 4.3 meters per second. So what this is asking us is to find the average force on each ball. Newton's second law says that for every action there is an opposite and equal reaction. So because these balls both have the same mass, the force that A applies to B is going to be equal to the force that B applies to A. So we just need to figure out the force for one of the balls, and then it will be the answer for both. So let's look at the second ball, the ball B. The velocity of ball B to begin with was 0. The velocity of ball B after the collision is 4.3. The mass is 0.28 kilograms. And the time it takes the collision to happen is 330 microseconds, which when we change that to seconds, we have to go 6 to the left. So we get 0.00033 seconds. So we can plug this into our impulse equation. The mass is 0.28 kilograms times V2, which is 4.3 minus V1, which is 0, equals force, which is what we're trying to find, times time, which is 0.00033 seconds. And then when we solve for force, we get 3,600 newtons. For the rest of the problems in this lesson, we are going to be using this equation. So in this case, we have a block of wood. That's going to be object 1, and it's sitting there on the table. And then we have a 4-gram bullet. That's going to be object 2. On the right-hand side, object 1 is still going to be the block of wood, and object 2 is still going to be the bullet. So when we start out our equation, we're going to put information in for the wood first. We have a 2.5 kilogram block, and it sits on a frictionless table. If it sits still, its velocity is 0. Now we're going to do the mass and velocity for the bullet. Its mass is 4 grams, but we have to move that 3 to the left, and we get 0.0004 kilograms, and it has a velocity of 420 meters per second. It's going to hit the block and go completely through. So now the block, still having a mass of 2.5 kilograms, is going to be moving at some velocity that we want to find out. And then the mass of the bullet is still 0.0004, but now it's moving at 230 meters per second. In this case, we have this small cart that's going to collide with a bigger cart. Our first object is going to be cart 1, and then we're going to have cart 2, and then on the other side, we're still going to have cart 1 and cart 2. Cart 1 has a mass of 0.25 kilograms, and it's going to have a mass of 0.25 kilograms afterwards, too. Cart 2 has a mass of 2 kilograms, and it's going to have a mass of 2 kilograms afterwards as well. So here we need the velocity of cart 1 to begin with, which is 1.1. The velocity of cart 2, it's at rest, so 0. After the collision, the small cart recoils. Recoils means that after it hits, it's actually going to move backwards. So this 0.850 meters per second needs to go in as a negative. And then we want to solve for the velocity of the bigger cart afterwards. Okay, this is one of these problems where we have an inelastic collision, where the two objects are going to stick together after the collision. So we have a 0.3 kilogram bird flying at 6.1 meters per second. And then we have this insect. It has a mass of 0.01 kilograms, and it's flying straight toward the bird. So that's going to be in this direction, so negative, with a speed of 30 meters per second. The insect flies into the bird's mouth. So now our mass is going to be the mass of the bird plus the insect. So we're going to have 0.3 plus 0.01. And we want to find the velocity of the two of them together after the collision. In this problem, we have this 1,000 kilogram Cadillac, and it's moving at 4 miles per hour. So we have 1.78 meters per second. Now we want all of that momentum to cancel out with this 2,000 kilogram Volkswagen. So we just do P, which is mv, and then mv over here. So we're going to solve for the velocity that we need the bigger car to go to totally stop this smaller car.